This is tape 253. We're continuing identities. This is identities part 2. All right, so let's look at the first example. And again, this is just some more similar to part 1, but we have some more concepts and a few more algebra things to talk about. So looking at example 1. All right, we have this times the parentheses. And there's several ways of doing this. The quickest way, and that's not what we're after, but the quickest way is to say, well, hey, this is the cosecant squared of theta. I left out a theta there. And then what is 1 minus cosine squared? So just start off with replacement. 1 minus cosine squared is sine squared. And now, listen to this concept. Secant, cosecant times sine. Cosecant times sine is what? 1. All right, now what I want to use this one for is to press this concept. We have the identities. The sine of an angle is equal to 1 over the cosecant of the angle. Well, that's true if this is squared, this is squared, this is cubed, this is cubed. So these identities, the first 5 identities that are written in textbook, are true for any power, provided it's the same power. Whereas 6, 7, 8, the sine squared plus the cosine squared is equal to 1, is only true for sine squared plus cosine squared, because that's based on x, y's, and r's. 1 plus tangent squared is equal to secant squared. That's only true for 1 plus tangent squared equals secant squared. But the other 5 identities are true for any power. Well, that means then, this is the same thing as saying cosecant times sine, that's 1. So then that would mean 1 squared. Okay, so that's one concept I want to show there. Another way of getting this, if you do not see that method, is to, what's the rule? When in doubt, change everything to sine and cosine. So let's come over here and make this 1 over sine squared of theta times 1 minus cosine squared of theta. All right, let's see. Well, this times 1 is 1 over sine squared. And this times that is cosine squared over sine squared. All right, well, what is 1 over sine squared? Well, that's cosecant squared. Again, remember sine and cosecant reciprocals be moved up and down. If that's squared, it's squared here. What is sine, cosine over sine? Forget the square for a minute. What is cosine over sine? Well, that's cotangent. If they're both squared, then it's cotangent squared. And here you have it. What is this equal to? Well, that's equal to 1. Again, if you don't see that, then you just go through your memorization processes. What's cosecant equal to? It's 1 plus cotangent squared minus this cotangent squared, and what happens? You still get the 1. All right, so the point of this one I wanted to point out was the idea of the first 5 identities of being, if the cosecant cubed is the same thing as 1 over the sine cubed. The cosecant to the 5th power is 1 over the sine of the 5th power, and so on. All right, let's look at example 2. Some of the same. It has part of what we did in part 1 tape, but again, just some more steps. Well, the rule is, hey, look what you have over here. We have secant, so I want to get that to be secant. So I want to change this to secants. Well, there are 2 ways. The quickest way to do this is to do algebra factoring. So we have the tangent squared minus secant squared times tangent squared plus secant squared. Well, let's see. What is tangent squared minus secant squared? Well, that's a minus 1. And this is not any identity. Now, if you don't see that minus 1, let's go ahead and take another step. Let's change everything secant squared here. Well, wait a minute now. You remembering, look at the other side? Everything is secant. So let's change everything over here to secant. So tangent's what? Tangent is secant squared of x minus 1 minus secant squared of x. And tangent is secant squared of x minus 1 plus secant squared of x. All right, well, let's see. This drops out. We get a minus 1. This adds up, and we have 2 secant squared of x minus 1. And now minus times this minus is a plus 1. Minus times this is a minus 2 secant squared of x. All right? So that's a way of getting that problem done. Now, again, listen closely to a concept. This is the best way to work this problem. A concept, though, is to do it this way. This side over here has secant. So let's change everything to secant. Well, that means tangent to the 4th power. And you need to know this, like in Calculus 2, a lot of times you deal with things where tangent to the 4th or sine of the 4th is tangent squared squared. So tangent to the 4th is tangent squared squared. So that means that's secant squared minus 1 squared minus secant to the 4th. And now you multiply that FOIL method. First times the first is secant to the 4th minus 2 secant squared plus 1 minus secant to the 4th. And you have the answer. So here, just in 2 steps, but that's not the point. The point is that's just another way of doing it. If you have only sine on this side, go over there and change all that to sines. If you only have cosine on one side, go make everything on the other side cosine. That's a possibility. I'm not saying that's what you do every time. I'm saying that's one thing you have to look at. A lot of concepts of identities is to sit back for a minute and just kind of look and think, and don't just start writing things down, and kind of decide which rule you're going to use at this time. Okay, let's look at the next example. We have 1 minus secant of y over cosine y minus 1. When in doubt, change everything to sine and cosine. Well, that's the way I have it in the notes. I'm going to show you that, and I'm going to show you another way in a minute. All right, change everything to sine and cosine. So that's 1 minus secant is 1 over cosine. And cosine, keep it like it is. All right, now we have a fraction. We have a fraction over number here, so we want to get a common denominator. Common denominator is that. So we're going to multiply everything by the cosine of y. 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 So cosine of y times 1 is cosine of y. Minus, drops out 1. Down here we have cosine squared of y minus cosine of y. Well, let's see. Common factor. Factor out of cosine of y. And I'm going to do this just one step on the board. In the notes it's another step. But right here I'm just going to come back and factor out the cosine of y. If I factor cosine of y there, that's a 1. And we're going to take one of those out. And so we have the cosine of y. And look what happens. So we have left 1 over cosine of y. Which is what? Sine, cosine, tangent, all those can be moved up. Cosine moves up as secant of y. All right, so the point of this one was, one way of doing it is change everything to sine and cosine, do algebra. All right, now let's go back at the top of it and look at another method. Just requires less steps, but it's still no difference. Either way, it gets the job done. What I want is secant. This is what I want. So what I'm going to do is multiply the top and bottom by what I want. So secant times 1 is secant of y. Secant times secant, that's secant squared. Secant times cosine, that's 1. Remember reciprocals. Cosine times secant's 1. Sine times cosecant's 1. Tangent times cotangent's 1. So that's 1. And then minus secant. All right, then we do the same step we had a while ago, factor. Factor secant out, and we have 1 minus secant divided by 1 minus secant, and those drop out. So we get the same answer. So that's two different ways of working the problem. Just get the job done by algebra and replacement. All right, let's look at now example 5. And please hear this. Listen, 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 listen. Concept in mathematics that I have a hard time getting across to students in lots of different ways in mathematics is this. If you have a single term in the denominator, if you have a single term in the denominator, no addition or subtraction, and you have a bunch of addition or subtraction on the top, what you do is change and put each numerator over that denominator. Split it up and write it as cotangent over tangent minus sine over tangent plus secant over tangent. There's so many times, not just with trig, but a lot of other things, that what you want to do when you have a single term in the denominator is to divide that into each numerator expression. All right. Now we work 3 individual problems. All right. Now again, watch and listen on this type of thing. Here's one way of doing this. I can move tangent up. Remember, tangent, cotangent, I can move them up and down for just that fraction. So I'm going to move this up, and that makes 2 of those up there. So it gives me cotangent squared. Hey, keeping an eye on the right side, keeping an eye on the right side. That's what I wanted. I got it. Okay, great. I got that part. And I got to have cosine here. Well, what's the rule? When in doubt, change everything to sine and cosine. So I will leave this sine up here, and down here I will change this to sine over cosine. Plus, all right, secant is 1 over cosine. Tangent is sine over cosine. When in doubt, change everything to sine and cosine. Let me point out something right here. Right over here. If I didn't see that, I could change that to sine and cosine. Sine and cosine. And still get there eventually. All right, let's continue here now. What do we get here? Well, this is the sine over 1 divided by this. So you take the denominator fraction, invert and multiply. So I'm going to write it here and then erase it. So I would have the sine of theta over 1 times inverting and multiplying by the cosine of theta over the sine of theta. Well, look what happens. The sines drop out, and sure enough, my answer here is cosine. So when you invert and multiply all this, it becomes cosine. All right, what about this one? Plus. All right, well, this would be 1 over cosine times invert and multiply would be cosine over sine. What happens? Cosines drop out. So all of this ends up being 1 over sine. Okay? Now, I want you to pay attention to something here, too, because a lot of teachers, especially if you're in my class, is I count off points here. If you tell me this goes straight from here to cosecant, I count points off. You must show me this one step in between. You must show me what this step gives you. This step gives you 1 over sine. Now the last thing, 1 over sine, is cosecant of theta. And the reason I do that is because I'm not sure that you really know that. In other words, I make you show enough steps that you show me that you know your identities and you know your algebra. So don't skip steps or you get the problem counted off. Okay, one more statement on this one, then we'll go to the next one, and that is when you have a single term of the denominator, you divide that denominator into each numerator function up here. Okay, each numerator term. All right, let's look now at the last example. Okay, and I've tried to point out in these examples these are the concepts. The fifth example was to point out what you do with those 4 or 5 problems that you'll have in the textbook to deal with a single term of denominator. Example 4 is where you kind of concept where you multiply the top and bottom. That's the best way to do that. Okay, example 6 now. Usually you have about 4 or 5 of these in most exercises, most trig books. And this is the concept of how do I get rid of the square root of fraction? You know, they use that concept of rationalizing the denominator. That's not the purpose. Here's what the concept is. I want to get from there to there. So what do I do? Well, in all of these problems, what you do is multiply the top and bottom. Now, what I want to do on this one is work it the longest way first, then I want to come back and do the shorter way. It's not really short either way. To show you what happens. All right, I want to make this a square. For instance, rationalize the denominator. If I have 5 over 2, you're taught to multiply the top and bottom by 2 so that the top may not come out to be, but the bottom comes out to be itself, right? No, that's not the way you're supposed to learn it. You're supposed to learn, you multiply the top and bottom so that you make the bottom a perfect square, not itself. A perfect square. All right, now let's do it the way that you may think, and that is multiply by itself. So we'll multiply the top and bottom by the denominator. All right, and so I have the square root of first times the first is 1 minus middle term drops out, minus cosine squared of beta, all over, parentheses, 1 minus the cosine of beta squared. Well, that's great. That's the square root of a parenthesis squared. But before we do that, let's do this. What is 1 minus cosine squared? Well, that's sine squared. And now what we have is the top is squared and the bottom is squared, so the square root of the top is sine. The square root of the bottom is 1 minus cosine. But that's not what we wanted over here. That's not what the problem is asking for. So what do? Well, we multiply top and bottom to make it what we want. Okay? So what happens if we multiply... let's see, what do we want to multiply by? 1 plus the cosine. Is that what we want on? Yeah, that's what we want on the top, so we'll multiply the top and bottom by that. All right, now again, watch this. This 1 minus cosine times 1 plus cosine is 1 minus cosine squared. And what is 1 minus cosine squared? Well, the identity, sine squared. And now that divides out, and we finally get what we wanted. Took about 4 more steps, but it still worked. Now, let me show you another way of doing this that gets it a little quicker. And here's how you determine which way. If I multiply the top and bottom by 1 plus, you see, look, that's what I want over there. I want on the top a 1 plus. So if I multiply 1 plus cosine times 1 plus cosine, that's going to be that parenthesis squared. So that's going to give me the answer. So sometimes you may want to look at what makes the top work out, and then just hope the bottom works out, and it will on identities. All right, so multiplying the top, then we have 1 plus cosine of beta in parenthesis squared, and 1 minus cosine squared. And again, taking an extra step here, this is 1 plus cosine of beta squared. And this is what is 1 minus cosine squared? How many times have we been doing that? 1 minus cosine squared is sine squared of beta. See, more often than not, that identity sine squared plus cosine squared equals 1 will be seen this way rather than sine squared plus cosine squared is equal to 1. It will usually be seen 1 minus cosine squared or 1 minus sine squared. All right, what do we have? Square root of something squared, square root of something squared. So therefore this is 1 plus the cosine of beta, and this is equal to the sine of beta. And that happens to be what we wanted. So this is a shorter method, not a better method, a shorter method. Okay, this concludes the examples that I think are necessary to work most of your first 40 or 50 problems in most exercises in trig books. Let's look at kind of review these again. Example 6 is the concept when you have a square root, you're going to multiply the top and bottom. And kind of the deal is to multiply the top and bottom, whichever one that kind of fits over here. If you have a 1 plus, then go do that one. All right? Number 5, you look at your notes. Number 5 is the concept of what? If you have a single term in the denominator. Number 4, the concept there is to change everything to sine and cosine, or if you can pick up on a shortcut method, multiply the top and bottom by something. Makes it work. Okay, number 2. The concept there is either you have to factor or you change everything to what the right side is equal to. Okay, you always should look on the other side of the identity, and if it has a single function, just a one function, then go take the other side and change it all to that function and then do algebra. And in the first one, the concept there is, I was trying to show two concepts there, but concept in the first one was that knowing that these identities, cosecant is equal to 1 over sine, knowing that those are true for any power, as long as they're the same power. Okay, I hope this is sufficient to give you some examples, some concepts, some rules to work with identities. This concludes then tape 253.